yesterday we got to here, and we were just about to plug in, figure out numbers, to plug in. To the left of -2 and to the right.
-3.
You didn't say 10.
Because 10's not negative.
You can have a -10. Yeah. I mean,
but that's not as good.
You're not as good.
Okay, so if we plug in -3.
Whoa.
We shouldn't have said 10.
If we plug in -3.
What? You said it. Oh, hold on.
If we plug in -3, that's going to be a positive. This is always, ooh, that's a nice color. This is always positive because it's just, it is. So positive and then times a negative, so this is negative. And then when I plug in 10, I get positive times a positive, so this side is positive. And the directions wants to know where is it concave upward, concave down. So it's concave down where?
Negative. Oh, wait.
Negative 2 to infinity.
Negative infinity to -2.
There you go. Yeah, it's over to the left of -2 is where it's negative, which means it's concave down for the second derivative. And it's concave up then. -2 to infinity, yeah. So that makes x equals -2 is a point of inflection.
Cool baby.
Because that's where it changes the concavity.
Now we have a division.
Yes. Woo woo.
Hey, but they already gave us that prime.
Wasn't that sweet of them?
Yeah. What about another stuff?
Glad you did too.
Yeah. But now I gotta do that whole thing.
F double prime of x.
Oh,
Low B.
Yes, good. Low D high. Nobody used that song, but they used the other one.
But it's because all the other ones had it, like all of the old ones had it in it.
Wait, how many people did the thing?
I did it. And it
4
helped
of
my
us.
grades so much.
It did help grades, yeah.
It helped my lot too.
Yeah.
I have an A now, guys.
Okay.
Barely, but I got one.
Low D high minus high D low. Square the bottom. And away we go. The quotient. Okay. So it's -6x on top and x squared minus 3 squared on bottom. And now we want to find our possible points of inflection. So they occur when this is either equal to 0 or where it's undefined. So equals 0 when the top equals 0. So that's when x is 0. Or when the bottom equals 0. That's when it would be undefined. All right. So number line. Double prime of x. We have, yeah, 0 and positive square root of 3.
What is square root of 3 like? About
1.7 something.
so -2.
Okay. and -1, 1 and 2.
Yeah.
Now, whatever we plug into the bottom, what's going to happen?
Huh? Math. That's gonna change.
Yeah, when I square it on the bottom, what happens? It becomes positive. So it doesn't even matter what's on the bottom. It's always going to be positive.
Fun.
Because whatever it is, I square it and I subtract 3, but then I square it again.
Yeah.
So it's always going to be positive. So I really only have to plug it into the top.
So, yes.
So first one's positive, positive,
Negative.
negative, negative.
Fun.
I thought so.
So the only cusp is zero. Or not cusp.
Not cusp.
One
Point of inflection. It is concave down from 0 to the square root of 3, and then from square root of 3 to infinity. Why can't I just say from 0 to infinity?
Because
We don't know.
because it's, I don't know.
What's going on in the square root of 3?
I don't know.
When you have a rational function, if I were to graph that,
Is there a
Oh,
hole?
is it?
Is there a hole?
no, holes when you have the exact same thing on
Cusp.
top and bottom. Huh?
Cusp.
Not a cusp.
I'm trying to think what it looks like.
Yeah, can you draw it?
What if
Wait,
Well, if I draw it, I'm going to tell you.
Wait,
Is there an asymptote?
It does do one of those things.
It's
Yes,
a-
asymptote. Yes, that was it. Yes.
Like it has this.
So, yeah, when a rational function is undefined, that whatever the bottom equals 0, that's going to be your vertical asymptotes. So that's why we don't include those. Those are
it
just
skips
dotted
it, it just
lines.
goes, yep.
Yeah. But they're both concave down. And then it's concave up, then from negative infinity to negative square root of 3, and from, oops, I forgot the meaning, negative square root of 3 to 0. And x equals 0 is the only point of inflection. Okay, so the next part is talking about how the second derivative we just figured out is used to figure out concave points of inflection usually. But it can also be used to figure out maxes and mins. Pretty snazzy. So if f prime of x, so the first derivative is equal to 0 or undefined, at some point we'll say x equals a. Then f of x has a possible relative max or min, which we already knew that. Those are called critical values. So if you take a, which is what we got when we took the first derivative and said equal to 0 or where it's undefined. So the possible relative maxes or mins. And you put it into the second derivative and it's less than 0. Then f of x is concave down, because second derivative is negative, that means concave down, which means x equals a is a relative max. Because think about it, if it's concave down at a, then a has to be a maximum. stuff on the space. Number 2. If f double prime of a is greater than 0, then f of x is concave up at x equals a. Which means x equals a is a relative minimum. And that makes sense, concave up. It's going to be down at the bottom. And then the last one, 3. If f double prime of a equals 0 or is undefined, then no conclusion can be made about x equals a being a relative max or min. But most often, x equals a then is a point of inflection, which just means it's usually doing that thing.
When do we take the ACT for free? Like the
February 29th or something.
When?
We got an email about it.
February?
February? I'm already taking one in
I
February.
signed up for that value one in February.
I'm going to
That's
ASU.
That one's on the 6th, but the school will give one on like the 29th or something like that.
Bruh.
There's like 29.
I don't know.
The what?
There's not 29.
Oh, then it's like the 19th. So no, I don't know.
Oh yeah, February.
It was in my email. 1 second.
Okay, so let's do this one. We're going to use the second derivative just to figure out the relative extrema. Okay, so first, you got to find the first derivative and find the critical values.